We're now going to look at a way to measure distance between 2 points in the Cartesian system. We're going to come up with a formula for doing this that is called the distance formula. Now, when you graph in the Cartesian system, you are plotting points that are represented by ordered pairs. My first point, I'm going to call it x1, comma, y1. The next point we will call x2, comma, y2, just to represent two generic ordered pairs. Now, what we're trying to find is the straight line or shortest distance, call it D, between those 2 points. We will come in and sort of sketch in an imagined right triangle. And we want to make it a right triangle so that we can be able to use the Pythagorean theorem. Now, since this horizontal side starts at x value x1 and ends at x value x2, the length of this side then will be x2 minus x1. And this might remind you of what you did when you found the slope of a line, because you were having to measure rise and run, and we're doing it in a very similar fashion. Now, the vertical side starts at a y value of y1, stops at a y value of y2, so its length would be y2 minus y1. Now, since the hypotenuse here is the distance we want to measure, we can basically say that hypotenuse squared, which we are calling d squared, is equal to the x2 minus x1 quantity squared, which is one of the legs, plus the y2 minus y1 quantity squared, which is the other leg. Now, taking the square root of both sides, we find the distance formula is the square root of x2 minus x1 quantity square plus y2 minus y1 quantity squared. And that is a formula that you'll need to be able to memorize and therefore use it correctly. And speaking of using it correctly, let's just come up with a couple of ordered pairs, a couple points, and find the distance between them. We will start off with a point down here in third quadrant, and we'll call it -5, -3. And we'll find the distance between it and a point over here in fourth quadrant, and we'll make that point 3, comma, -2. Now, I suggest that before you use the distance formula, that you have the formula written in front of you, and you have your ordered pairs there in front of you, and it doesn't hurt to label them. So I'll call this x1, y1, x2, and y2. So the distance between these points would be distance equaling square root of x2 minus x1, which is 3 minus -5 quantity square, plus y2 minus y1, which is -2 minus -3, and then quantity square. Remember that minus a negative becomes plus a positive, so this is a 3 plus 5 squared plus -2 plus 3 squared, which is the square root of an 8 square plus a 1 square. And if these numbers had turned out to be negative, we would have needed to keep the parentheses. And I probably should anyway, because at this point when you square, no, the square root doesn't cancel these squares. We have to go ahead and square it out. We should get a positive result for both of these, because again, we're squaring. Whether it's positive or negative, that has to come out positive. So I will go ahead and add And what we have with the square root of 65 is in fact an exact answer. There's no round off, there's no approximation. Now if you want to know approximately what is this, we'll go to the calculator and go ahead and take the square root of 65. We find that to be roughly 8.06. So whatever units you're using to measure, 8.06 is the distance between those, whether it's inches, feet, miles, whatever. That is the distance between those points.